In a previous video, we saw these two results. When you raise a number to the power of 0, the answer is always 1. When you raise a number to the power of 1, the answer is always the number itself. We want to look at another result. Let's clean up part of our board here. And remember, these up here are the 3 laws of logarithms that we looked at in previous videos. Now, suppose we take the number 2 and we raise it to the power of 5, and that is divided by 2 to the power of 6. Now, according to the second law that we have here, this should be 2 to the power of 5 minus 6, which is 2 to the power of negative 1. Now, let's look at it more closely, or in more detail. 2 to the 5 is 2 by 2 by 2 by 2 by 2. So we have 5 2's, and they multiply each other. Divided by 2 to the 6 is 2 by 2 by 2 by 2 by 2 by 2. 6 2's, and they all multiply each other. Let's do some cancelling. 2 cancels 2, 2 cancels 2, 2 cancels 2, 2 cancels 2, 2 cancels 2. We have 1 2 left down here. So let's see what this amounts to. At the top here in the numerator, all we have left is 1 divided by 2. What this is saying is that 2 raised to the power of negative 1 is 1 over 2. Let's try again with another number. 3 raised to the power of, say, 4 divided by 3 raised to the power of 5. That would be 3 to the 4 minus 5 according to the law of indices, which is 3 to the negative 1. What we would have here is 3 by 3 by 3 by 3. That's 3 to the 4th power. Right? Where you have 3, the index is 4, divided by where 3 and the index is 5. So you have 5 3's, and they all multiply each other. Alright? So if we cancel down, cancel 3, 3 cancels 3, we cancel again, we cancel again, we end up with 1 over 3. So 3 to the negative 1 is 1 over 3. Suppose we have 4 raised to the power of 7 divided by 4 raised to the power of 8. This would be 4 to the 7 minus 8, which is 4 to the negative 1. But what does this amount to? We have 7 4's over 7 8's, no, 8 4's I mean. Now, if we should cancel down, they all multiply each other, but I won't bother to put the multiplication sign there. Cancel, 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 cancel. What we have left here is 1 over 4. So this is saying 4 to the power of negative 1 is equal to 1 over 4. Well, now, it seems as if we have a pattern here. where if we take a number x and raise the number x to the negative 1, what we end up with 1 over x. It's 1 over x. Now, that is another result, right? So if I have x raised to the negative 1 is equal to 1 over x. Now, let's go a little further with this result, and let us say we have 3 raised to the 4 divided by 3 raised to the 6. What would it be? It's 3 to the 4 minus 6, which is 3 to the negative 2. What would that be? Well, let's see. 3 to the 4 means you have 4 3's and they multiply each other. 3 to the 6 means you have 6 3's and they multiply each other. If you cancel down, you end up with this being 1 over 3 by 3, which is 1 over 3 squared. So therefore 3 to the negative 2 means 1 over 3 squared. Suppose we have 3 to the 4th divided by 3 to the 7th. This would give 3 to the 4 minus 7, which is 3 to the negative 3. But what is that? You have 3 to the 4 means you have 4 3's up top divided by 3 to the 7 means you have 7 3's down the bottom. And when you cancel down, 3 cancel 3, 3 cancel 3, 3 cancel 3, 3 cancel 3, what you have is 1 over 3 by 3 by 3, which is the same as 1 over 3 to the power of 3. So therefore, this is 3 to the negative 3, and you get 1 over 3 to the 3. Let me partition the board here. What I'm getting is 3 to the negative 3 is equal to 1 over 3 to the positive 3. Whoa. Interesting. Now, what I want you to do is to repeat this a few more times with numbers other than 3 and with powers other than 4 and 6. Make the top power, the numerator power, less than the denominator. So when you subtract them, you get a negative number. And you're going to find out that when you have a number, let's call it x, raised to a negative power, let's say to the negative a, you will get the same thing as 1 over x raised to the positive a. And that is another result that we get. In fact, when we said x to the negative 1 is equal to 1 over x, it's the same thing. It's just that we can write this as 1 over x to the 1. Right? You see that? So therefore, let's erase some of what we have here. Therefore, x to the negative 1 is 1 over x to the 1. X to the negative 2 is 1 over x to the 2. X to the negative 3 is 1 over x to the 3. X to the negative 4 is 1 over x to the positive 4, right? X to the negative 1 is same as 1 over x to the positive 1. X to the negative 2 is the same as 1 over x to the positive 2. X to the negative 3 is the same as 1 over x to the positive 3. X to the negative 4 is the same as 1 over x to the positive 4. x to the negative 5 is the same as 1 over x to the positive 5, and so on and so forth. So x to the negative a is the same as 1 over x to the positive a. That's another result that you should remember. Alright? So those are some results that we have here. Now we're going to look at more results from the laws of indices, but we'll do that in another video. So I'll see you then.